Hi there, Lambda lovers. My name's Ian Brumby. I'm a serverless enthusiast and solutions architect based out of the UK. I'm delighted to introduce you to my AWS Lambda Hackathon project, Drone SoundAware, working title. A decade ago, we were told about drones. We were promised doorstep deliveries, medical drones delivering aid, armies of these zero-emission drones taking traffic off our roads. It's fair to say that outside of limited trials, we have not yet achieved these dreams. My background is from working with UK Air Traffic Control and the UK regulator. There are significant challenges with regulation here. However, its social acceptance is another key to unlocking large-scale operations. What? I can't hear you. Yes, right, these drones are noisy. Alongside privacy, a lot of the public resistance is going to come from this noise. So how do we get ahead of this minimize noise impact? How can AWS Lambda help us solve these problems in a scalable way? Enter Drone SoundAware, working title. A solution that allows drone operators to plan, assess, and optimize their flight operations, reducing their noise impact on the community. Okay, so let's get started. I'm going to cover the architecture and use of Lambda first, and then give a quick demo. Here's the basic architecture of the solution. I load gridded population data into DynamoDB on the initial deploy. This is just the UK data purely to keep the deployment times down. I'm using geohashes to partition the data in two different ways to allow efficient queries. There are 3 different Lambda triggers here. Real-time weather data is loaded from an event bridge scheduled rule. This ensures that drone operations are viable from a weather point of view. We've got Lambdas that are proxied by API gateway. They're there to allow users to populate the map, assess the proposed drone route, and post that route for optimization. And finally, we don't want the front end waiting around for the optimization to happen. Event-driven architecture is our friend here. The user post to optimize the route, it simply creates a record in the routes table in DynamoDB and returns an ID. Lambda picks up the insert from the DynamoDB stream and performs route optimization based on a variant of the A-star routing algorithm. I really wanted to demonstrate that it's possible to run compute-intensive operations in Lambda here at scale. And of course, we look to follow best practice. It's deployed with CDK. I've used a custom CDK Lambda construct, complete with Power Tools logging, X-ray tracing, and of course deployed on Graviton. Okay, let's go and have a look at it in action. So here's a demo of the front end. The bounding box API calls provide a summary of the high density population areas and the weather data for displaying on the map for context. You can open the operations planner and start to plan your route. Select the start and the end positions, and the route assessment endpoint will determine the impact of this flight. You can see here over 4,000 people could potentially be impacted by this one flight. Click Optimize and the front end will respond to AppSync. Once the event has been optimized and Lambda has completed and posted its results. As you'd expect, the optimized route is longer, but the population impact is reduced to less than 1,000. Okay, that's it for now. To get started, clone the repo, follow the deployment instructions in the README and get going. Bye.